G'day Year 10s, welcome to your chemical reactivity prac for metal reactions. So we're going to be experimenting with 6 different metals today. We've got zinc, magnesium, copper, tin, iron and aluminium. And we're going to be sticking them in 50 ml of 3 molar hydrochloric acid. And you know this is the dangerous stuff when I'm even wearing gloves today. So what we've got here is an inverted cylinder, and it has a bit of oxygen or a bit of air there at the top, you can see, and we can measure off that starting value when we zoom in a little bit there. But right now the initial value says 22 millilitres of gas, so there's 22 millilitres of air in there. We're going to drop some metal in here, and this metal is sort of preloaded here into the green stopper. We're going to drop it into the acid. It's going to react, it's going to make a gas. The gas will flow up the tube and then start bubbling up through here, and this should start to come down. Now some of these metals will react, some of these metals will not react. You've made a prediction for which one will be the most reactive. We'll see if you're correct today, and then we will be able to do some calculations off it. Now as we go through, this, I'm going to be calling out some times. You should be looking for what level the water is at on the cylinder at that time. Take note, the cylinder is upside down, so if it's a couple here above 30, it's not going to be at 32, it's going to be at 28 because the cylinder is upside down. So be careful with that with your measurements. Let's make sure that's straight. Great. We've got my stopwatch. We're going to get started with our first one. I have some zinc metal here. Let's get this ready. Goggles for safety. And I'm just going to push the metal through and then hit start on the stopwatch. 3, 2, 1, now. Now zinc is slightly reactive, and you should be able to see on the zinc all these bubbles forming on the surface. So it will start to produce gas, but it's going to take a little bit of time before that gas builds up and starts to flow through the tube there, and we see a displacement occurring. So we are going to give that a couple minutes, okay, because it'll take a little bit of time. Luckily for you, we've got magic of video editing, so we'll skip through a little bit so that we can see it speed up rather than watching it in real time. Alright, so we'll sit down so you guys can see me properly. Okay, so that should have been about 5 minutes on timing there, and we can still proceeding, so feel free to use this time to keep gathering data. Zinc has had a reaction with the acid. If you remember back to Year 9 chemistry from last year, metal reactions produce hydrogen gas, and so if we were to capture some of that gas and drop a match into it, we should see it go pop. There's a lot of gas there, so it'd probably be a pretty big pop. But we're going to stop that one, and we're going to go on to the next one. It would continue to keep going. We can see here that the the metal has not fully dissolved. It is continuing to react there. And I'm going to put this off to the side where it will continue to react and produce hydrogen gas for the room. However, we're probably not going to see much of a difference in here. We're probably not going to see much of a difference in how fast it was making hydrogen gas. Okay guys, this is metal 2, aluminium, not aluminum. We're not Americans. Now, before we do aluminium, just as a quick reminder, aluminium has 3 outer electrons. It should be fairly reactive, but it really likes air. So even though this is being pre-cleaned by Miss Haig, it's a very nice shiny metal. I'll show you, there's the tin. I'll show you what it looks like before it's gone in. So you can see here, it's a very shiny silvery metal. It's all been cleaned off. However, it will be reacting with the air just around it right now and forming an oxide layer to protect itself, because it's like that. So, okay, let's get ready, students. 3, 2, 1, and in. Make sure it plugs in. Now, if we hold it up here, when we did the zinc, we saw bubbles starting to form pretty much immediately across the surface of it. Now, I'm not seeing any bubbles here. So I'm going to give it a minute. If we don't see bubbles on the surface in a minute, we would be able to say that if there is a reaction, it's so slow that we'd be here all hour just to watch one piece of metal react. That's coming up on a minute. So, if we have a look right at the surface of it, we can see very small amounts of bubbling starting to form there, right, around the outer layer of that aluminium. Now, compared to zinc, it's not much, but we'll give it another minute because it might just be enough gas. Might be. Big emphasis on the might. And we'll see if we can get anything to come out of it. Now, if you've been through my Year 8 class, you may remember the story I've told about Napoleon with his aluminium plate. Remember, until very recently, aluminium was a very, very rare metal. The fact that you've got some at home, the fact that you've got some, you can go down to the corner store and buy a can of aluminium, that would be remarkable going back a couple hundred years. It wasn't until we started working with electricity and we discovered running electricity through stuff would help separate out metals that we really got a handle on digging up aluminium. And now Australia is very, very good at that. So he's bubbling, he's producing some small amounts of bubbles. We'll give him a chance, we'll give him a little bit longer, we'll see what we get. Now, for the sake of your sanity, we have to sit here and watch this. But for the sake of your sanity, you might just want to skip forward a couple of minutes and see, did anything actually happen? And then go back and watch it for data. Now, I didn't read out what it started at, but I'm sure you guys can just rewind the video a little bit and see what it is. But now we're starting to get gas coming through. Oh, that's interesting. So if we have a look at the aluminium, we can see the bubbling is a lot more vicious than it was when it first started. Now, what that tells me is that it's burnt through that oxide layer, and now it's actually reacting with the metal. And so now, because aluminium being a +3, being fairly reactive, is producing quite a significant amount of gas. So how you interpret this data in your numbers, and it's even leaving bits of metal behind. Aluminium chloride is this disgusting grey colour there. Kind of look good, it's great. So, how you want to interpret your data. Do you want to look at this, go, well, it didn't produce any gas for a period of time, but then it started to produce all of a sudden? So do we mark when it starts to react visibly, or do you start it from when we first dropped it in? Now that would be something in an analysis that you would have to argue about in your interpretation of results. But that is fantastic. And we filled up the whole cylinder. So we're going to have to stop the cylinder bit there, but this is going to continue to react for quite some time. Okay, metal 3, guys. We're going to do copper this time. Copper, remember, is a transition metal. It's sitting there in the middle of the periodic table. I don't really expect this one to react, but we'll see what happens here. So, getting ready in 3, 2, 1, and pop. Bring it around the front here. So, as we can see, we've got a nice silvery, brownish red colour metal there. Nice and shiny, it's been freshly cleaned. Doesn't seem to be doing anything at the moment, but hey, like with aluminium, I could be wrong. So we'll give it a little bit of time and we'll watch to see what happens. We're coming up on a minute, but unlike the aluminium, I am not seeing any bubbles on the surface of our copper. So I'm going to suggest that this is not reacting with the hydrochloric acid at all in this time frame or with this strength. Now, if we went and got the super strong stuff, we could probably dissolve it. Coming up on 2 minutes, I can see no bubbles. I'm going to call this one. I'm going to say there was no reaction for our copper, so we'll stop that one there. Okay guys, metal number 4, we're up to tin now. Remember, tin's over on the right hand side of our periodic table, similar column to aluminium, which may indicate it should react similarly to aluminium as well. So we're starting at about 21 millilitres there of liquid or air in the cylinder. Let's poke her in. Let me set a stopwatch and see what happens with a 3, 2, 1, poke. Okay, so no initial bubbles on it, but we'll give it that minute. We'll see if anything's starting to happen. Coming up at a minute. Don't really see any bubbles on it. So we'll give it the other minute like we did with the copper before we call anything. Alright, that's 2 minutes, but I do not see any appreciable amount of bubbling on the surface. So I'm going to suggest that this is being unreactive. So we'll finish off tin and move on. Okay, metal 5, we're almost to the end, guys. Now, in this case we're going to do iron, but I don't have any flat, thin pieces of iron, so we're going to use an iron nail. That will affect the results a little bit, and when you do your discussion for this, I'd expect you to talk about why that the changing of shape may affect the data that we see. So let's plop this in. This one at least I don't have to shove through, and we'll get started. 3, 2, 1, and in. Bring it around. and we'll give it a couple minutes to see if we get any bubbles coming off of it. Now, we could have done this with steel wool, but the steel wool is very, very fine and has a massively increased surface area, so it really wouldn't be even a slightly fair comparison. While the iron is thicker and it's rounder, so we do have a bit less surface area, it at least is slightly comparable. It's still at 21, so that hasn't changed. But if we look really closely at the iron, we can see small bubbles already starting to form around the nail. And we're at 40 seconds since I hit the timer. So this is pretty similar in pattern to how the aluminium went. So I think this is one we're going to leave for a little bit and see how it goes. To the 2-minute mark, and I'm not seeing a bubble moving yet through our tube. Well, we will give him just a little bit of time because iron seems to be going a little bit slower. We'll see if we can get a bubble by 3 to 4 minute mark. Alright, well we're at 3:30. There aren't a noticeable amount of bubbles. They are slowly coming off of it, but we're not seeing enough gas pushing through. So there's certainly a reaction rate, but our equipment is not fine enough with this setup in order to measure that reaction rate. So if you're going to do this experiment in a year 11 or year 12 class, this is the sort of thing where you go, well, we can see it happening, but we can't measure it, so we need a better way. We need to refine our technique to get a better way to measure it. We'll let it run out 5 minutes, which is the same amount of time we gave our zinc at the start, just to see if we can get a bubble. Come on, iron, you can do it, I believe in you. Okay, so we've seen some bubbles come off it, but we just haven't got enough gas to measure it using this technique. So this is a method that definitely needs a refinement. Okay. Alright guys, last metal, and we'll try to make this one as visible as possible. You can see this time I've actually got it all the way to the top. With zinc and aluminium, I didn't want to have it below this 10 centimeter mark. In case after 30 seconds I wasn't able to see where the gas got to, which, as we saw, it took a couple of minutes for some of their bubbles to come through. I know magnesium will not have this problem. Many of you have predicted this correctly. This is going to fill it up very fast. Normally you would use only 1 molar acid, so this would go a bit slower, but in this case we've got 3 molar acid just to get some of those other metals, and so this will go through very quickly. So starting 3, 2, 1, and now. And would be below your visible line, and the cylinder is now not quite full, but all the metal looks to be gone. So that's our last metal, guys. So there'll be some instructions for how to do your analysis. Keep an eye out for that. Thank you very much for watching. Have a great time.